welcome to video 2 for our 7-4 video series. In this lesson, we're going to take a look at exponential growth formula. So when an exponential function increases over time, we refer to it as growth. When an exponential function decreases over time, we're going to refer to it as decay. This video is going to focus specifically on growth, and then we'll pick up decay in just a little bit. Now, your growth and decay formulas are not given to you on the formula sheet. Now, this might seem like kind of a big deal, but we're going to show you kind of a hack to figure out how you can get these formulas using the compound interest formula that they do give you on the formula sheet. So, just to review, our compound interest formula that we looked at in video 1 is A equals P times the quantity 1 plus R over N raised to the NT power. All our growth formula is going to be is the exact same formula, but what we're going to do is everywhere we see an N, we're going to say that it's just going to happen one time a year. So we're just going to plug in a 1 where we had the N in the compound interest formula, and then we're just going to simplify. So we're doing R divided by 1, and if you do R divided by 1, anything divided by 1 is itself, so we get R. Just the same way with multiplication, if you multiply something by 1, you are going to get what you start with. So 1 times t is t. So this is how we derive, or how we can arrive at the growth formula, even if it's not something that they are going to give you. So this is not a formula that you will see on your sheet, but it's one that's going to be really easy to find. So now that we have our growth formula, let's take a look at an example. So we're looking at a colony of ants. We have 10,000 ants, and it's increasing by 15% a month. We want to know how many ants will be in the colony after 1 year. So we're going to have kind of the same basics as the compound growth formula. A is going to be the number of ants after a year, so that's going to be how much we have when it's all said and done. P is going to represent the starting number of ants, which is in this case going to be 10,000 is what we're starting with. R is going to be our rate of increase. It's increasing by 15% a month. Just like with our compound interest, we're going to need to change this to a decimal. So we'll need to move it over 2 places. So that becomes 0.15. And then T is going to be how many months we're letting the colony grow. So this is one thing where it changes just a little bit. It's not going to be T is always going to be years. It's going to be however many of the time periods that you're talking about. So T is going to be the number of months. We were wanting to know after 1 year. We have to do a quick conversion. 1 year is 12 months, so our T is going to be 12. Now all we need to do is plug this into the formula that we just derived. We are looking for A, so we still don't know what that is. We're going to plug in 10,000 for P, because that's how much we started with. We're going to do 1 plus our R, which our R we figured out now was 0.15, raised to the 12th power, because our T was going to be 12. Now we can do some quick short simplification on this, and a lot of times you will see this simplified as 1.15, but go ahead and add those together. But after that point we can just plug it into our calculator. When I plugged it into my calculator, I got 53,502, and I got 0.50105. Now we got to think about what we're talking about. We're talking about ants. It doesn't make sense to have 0.50105 ants, so we are going to need to round this to a whole number. So we can round 53,500, and that would round up to 3. So we have 53,503 ants. So just like in the meme we can see up here, there would be ants everywhere. Alright, we do have a U-try problem for you guys based on the actual population of Habersham County. Go ahead and give that a try, see how much that we have grown. And go ahead and check that answer, and then come back and see us in video 3. Alright, see you guys then.